Let's talk about a simple problem and how it could easily be addressed with Oracle Blockchain Cloud Service. To increase traceability of vehicle parts for a more efficient recall process, a major automaker recently integrated blockchain with their ERP software. 4 dealerships recently became participants to this network, each integrating their own ERP software, enabling them to share information on the blockchain. Let's think about how we would model this using Oracle Blockchain Cloud Service. The instance we will run uses segregated channels, a Hyperledger fabric concept, with which to ensure only privileged users or companies gain access to data. As you can see, the vehicle manufacturer has 4 independent channels to 4 dealers. Manufacturer can see the data from all channels, while dealers can see data within their own channel, thus enabling privacy. This is the Oracle Blockchain Cloud Service console. Here on the dashboard, you get to see high-level details about the blockchain network you've configured. In this particular setup, we have 5 organizations connected to the blockchain network we have founded. As you will see, organizations can either be founders of a new network or participants in existing networks. We have 2 independent peers that separately maintain a copy of a ledger. We have 1 ordering service that marshals the ordering of transactions into the ledger. We have 5 channels that help us maintain transaction privacy or petitioning, and 1 installed chain code or smart contract. We also get to see general blockchain health information. Here we have 100% of our nodes operating correctly, transaction execution details, and ledger summary information. On the network tab, we have a network summary at the top, where it explains again that we have 5 organizations, 1 being a founder, and 4 being participants. The founder being Detroit Auto, who is our automaker, and we have 4 participating car dealerships. Tab at the top, we get a summary that explains we have 5 nodes configured for the vehicle manufacturer, of which 2 of these nodes are peers, 1 being an ordering service, 1 being a certificate authority, and then finally we have a REST proxy. Oracle Blockchain Cloud Service enables you to interact directly with the ledger or blockchain network via REST. Now, that should make for a very familiar development experience for those who know how to write directly to a REST proxy. On the Channels tab, we get to see that the vehicle manufacturer is connected to 5 existing channels. If we take a look directly at John's supply chain channel, we get to see the transactions that are occurring or that have occurred and the blocks that have been committed for that particular channel. We also get to see chain code that have been installed on that channel particularly. And finally, we get to see the peers that are connected locally to that channel. On the Nodes tab, you also get to see the network topology. Here we can find that our 2 peers are each connected to separate supply chain channels with each of the vehicle dealerships. So we actually have 2 peers for redundancy. The peers are responsible for updating ledgers in addition to actually signing off on transaction proposals. This is a dashboard as seen by John's Car Dealership, a participating organization in a network founded by the vehicle manufacturer. It is 1 organization with 2 peers, 1 channel shared with the vehicle manufacturer, and 1 installed smart contract or chain code. As we can see, John's Car Dealership is a participant in a network founded by the vehicle manufacturer. John's Car Dealership has 2 nodes or 2 peers that are directly connected to John's supply chain, which is a channel shared with the vehicle manufacturer. So the ERP software of John's Car Dealership and also the vehicle manufacturer are connected directly via the blockchain, and they're using REST APIs to essentially share information. The channel as created by the vehicle manufacturer is called John's Supply Chain. So only the vehicle manufacturer and the car dealership, John's Car Dealership, can see the information on the ledger. If we go back to the dashboard of the vehicle manufacturer and we go to the supply chain network created by the vehicle manufacturer, we'll see that the ledger information directly correlates with what John's Car Dealership is seeing. So here, what we want to do is actually start executing some transactions. So we're using a curl command to initiate a RESTful call directly to the channel owned by Detroit Autos, which is our vehicle manufacturer. So we're creating a vehicle part with a serial number 1234 and sending it to Detroit Autos as the owner, in addition via the channel that belongs directly between Detroit Autos and Steve's dealership. So we get a transaction ID and a success. So what we can do is go to a rudimentary user interface that's been set up purely to allow us to query the transactions. So this dashboard allows us to see the transactions executed and visible to Detroit Autos and also Stephen's dealership. So if we type in a serial number in the query, we find that there's a transaction belonging to Detroit Autos that's been created. In addition, if we query that transaction on Stephen's dealership, we find also the same transaction exists as they're sharing the same channel. Okay, so if we then take this to Sam's dealership, this transaction doesn't exist because Sam does not have access to that same channel. So what we might want to do now is transfer that asset over to Stephen's dealership. So we see that we have access to Stephen's supply chain, Sam's supply chain, John's supply chain, and Jude's supply chain. We want to actually send it through Stephen's supply chain. We get a success and also a transaction ID corresponding to that as well. If we run the query again, we find we now have two transactions. The initial transaction to create the asset and a second transaction that actually transfers it over to Stephen's dealership. We can run the same query again on Stephen's dealership. And again, we have two transactions, one that creates the asset, and secondly, one that transfers it over to Stephen's dealership. Sam's dealership and Detroit Autos, a vehicle manufacturer, also have a shared ledger via a private channel between themselves. One of the assets on that ledger has a serial number ABG1239. And we see this asset initially was owned by Detroit Autos and then subsequently transferred to Sam's car dealership. We can run exactly the same query at Detroit Autos dashboard and find that this asset is visible at Detroit Autos. So we have an asset from Steve's dealership from the last query and also the new asset we just queried from Sam's dealership. If we try to run the same query at Stephen's dealership, we find that that asset is not visible to Stephen's dealership simply because it doesn't share a ledger between itself and Sam's dealership.